Hello, everybody. Welcome to the second part of 3.4, which is modeling and solving problems with polynomials. Today, we're going to be looking at word problems, and our goal is going to be to write an equation to represent the situation and then use that to solve the question being asked of us. Sometimes we will use the equation that we have written to draw a graph and use that to help us actually solve. Many of these questions can't really be done without graphing and then using something like Desmos or a graphing calculator to find the solution. Doing it algebraically is quite difficult. So if we were doing a test for this section, you wouldn't be usually solving, you would be setting up the equation and describing how you would solve. If you want, while you're doing your homework questions or your practice questions, you could use Desmos to actually find an answer for some of these questions. So our first problem, we're going to deal with a quadratic, and then we're going to look at a cubic and then a quartic. So the quadratic problems should be a review. You've done these in Math 11, but we will go through one anyways, because for some of you, it might have been over a year since you've looked at these types of problems. The question is, the other day I was golfing at Burnaby Mountain. Not actually, I'm a terrible golfer. I can't even make par on a putt-putt course. But nonetheless, on hole 6, I used my 7-iron and hit a beautiful shot right onto the green. Mentally, I created an equation of the ball's height in the air over time. My equation is h of t equals negative 4.9 t squared plus 34.3 t. The first part of the question is asking us to graph the height over time. So we've got two options here for graphing that are realistically what we would want to use. We could make a table of values, but that would be slow and not one of my choices. I could complete the square to put this into vertex form, but many of you probably haven't done completing the square since our conics unit way back a couple months ago. My third option, which is what I'm going to choose to do, is to factor out the 4.9 and the t so that I can find my x-intercepts, or in this case, my t-intercept. So if I factor out a negative 4.9 and a t, in my first term, I would still have t left. And in my second term, I would have minus 7. So if I divide 34.3 by negative 4.9, I get 7. So this means I have a t-intercept at 0 and 7. So the 0 comes from this one, and the 7 comes from this one. So once I have that, I know that one is going to go here and the other one goes here, 0 and 7. I also know this is an upside down parabola because my leading coefficient is negative. So I know that this is going to be some sort of arc like this. Okay. Now, the other thing is that I need to know some actual points. I probably need to know what my vertex is. So I could go back and redo this and complete the square. My other option is I could make myself a table of values. So I'm going to make myself a little table here. I'm going to need my calculator for this. So I'm going to pick, maybe I'll pick 2, 4, and 6. I know that my vertex is halfway, which would be at 3.5. So I want to include 3.5 as well, because then I know where my highest point that my ball will reach is. So maybe I'll do 2, 3.5. Let's do 2, 3.5, and 5. Start. Okay. So if I plug 2 into my equation, I would have negative 4.9 times 2 squared plus 34.3 times 2. This gives me 49. So my point is going to be over to the right by 2 and up by 49. So just a little bit shy of that grid line, because that grid line would be 50. And then I'm going to do 3.5. So I'd have negative 4.9 times 3.5 squared plus 34.3 times 3.5. This gives me 60.025. If I go over to 3.5, I'm basically on that line 60. Okay, and then 5, I'm going to have negative 4.9 times 5 squared plus 34.3 times 5, and I get 49 again. And that's because we know parabolas are symmetric. So since 5 and 2 are both 1.5 units away from the vertex coordinate, we know that 5 and 2 have to have the same y coordinate because of our symmetric property of parabolas. Okay, and I can connect my dots. Okay. I'm not going to keep these lines going. There's no arrows at the end. And that's because if I go below the x-axis or the t-axis, that would be a negative height. And so if you're on the ground, unless the ball is going into the grass, like under the surface of the grass, that doesn't make any sense. So now that we have this graph, we can use this to help us answer the next couple questions. So the first question is asking for how many seconds is the golf ball in the air? Well, at time 0, you launch the golf ball into the air. It goes up, hits a vertical height of about 60, and then comes back down and hits the ground again at time 7. So it's in the air for 7 seconds. And then the second question is asking what is the maximum height that the ball reaches? Well, the maximum height is that y coordinate of the vertex or the h coordinate of the vertex, which is at 60.025 meters. Okay. So sometimes graphing will help us figure out the answers to the questions, especially when you have really big numbers or really gross numbers, which often happens in a cubic or quartic problem. And that's where Desmos is going to come in handy for us. And so the big part here is if you can't set up the question, you can't graph in Desmos to begin with. So Desmos is very helpful, but if you can't, again, set up a question to graph, and you don't know what you're looking for, and you don't know what it's actually asking you to do, then there's nothing to graph. There's nothing. Desmos is useless. So really what we're looking for is, could you set up that equation? Do you know what the different parts are asking you to do? And can you graph this thing? So the next question is saying a packaging company has large quantities of cardboard that are each 28 centimeters long and 21 centimeters wide. So I find it helpful to draw myself a picture. So this is 21 centimeters wide and 28 centimeters long. Each box, or each piece is used to make a box with no top. So equal squares are cut from the corners. You're going to cut these squares out of the corners. Okay. And then what you're going to do is you're going to fold the sides up. So essentially what's going to happen is you're going to end up with a fold line here and here, here and here. And then you're going to end up with a box that looks like this with no top. Okay. So you would have to cut those squares out of the corners, because if you just try and fold up the edges, what'll happen is you'll end up with this weird overlapping section. So if you want to try, you can actually take a piece of paper, try folding up all the sides to make a little box, like a little open-topped box. And what'll happen is if you don't take the corners out to allow you to fold the sides up, then you end up with this bunched up piece of paper in the corner. Okay. So the problem is we don't know how big these little squares are that we're cutting out. So I'm going to call these little squares x by x squares. So this is what we're cutting out, and they're all x by x. They're all the same size. If they're not the same size, you're going to have a lopsided box. Okay. If I cut out these x by x squares, what's going to happen is this is going to end up being the bottom of my box. And then those other 4 rectangles will fold up to be the sides. Okay. So when I make my new box, what this means is when I fold up the sides, the short sides, the 21 centimeters, I've taken off 2 squares. I've taken off this square, and this is all that's left. Okay. So this side here is going to end up being 21 minus 2 times whatever x is. So if I take off a square of size 5 by 5, I've taken off 5 from one end here and 5 from one end here, leaving me with 11 centimeters left. So that would be 21 minus 2 times 5. Okay. But we don't know how much we're taking off. The question is asking us to find the dimensions of the box that create a maximum volume. So we are being asked about the volume of a box. Well, I know that volume of a box that looks like this is a rectangular prism, is length times width times height. Well, I can't maximize that volume if I don't know the length, the width, and the height of the box. So we've got a new width here already. It would be 21 minus 2x. We also need to know what the new length is and what would the height be. The new length, well, I started with a length of 28 centimeters. And again, I'm cutting off 2 squares. So this means my new length will be 28 minus 2 times whatever x is. Now the question is, well, how tall is this box going to be? If I think about this logically, I know that when I fold this up, the height of my box is this distance here, which is the same here, the same here, and the same here. And again, if you tried this with a piece of paper, you can see that when you fold up that edge, however big this rectangle is, this vertical distance or horizontal, depending on which rectangle you're looking at, that distance, when you fold that up, that's how tall your box will be. Well, that distance is x. If you look at the diagram, you can see that's the same as this distance, which is x. So my height here is x. Now I have a length, which is 28 minus 2x. I have a width, which is 21 minus 2x, and I have a height, which is x. I have an equation for volume of my box. Now, this is a cubic. If I graph this, I can find out where the maximum is. Similarly, if I had a quadratic, if I graph it, I can find the vertex. Okay. So first, I need to know what this thing might look like so I know what I'm looking for. Well, I know that it either looks like this or it looks like this, right? So I'm looking for, well, if I were to multiply all this out, what would my leading coefficient be? Would it be positive or negative? So if I multiply this out, I've got this x term, and this x term. This one's negative, this one's negative, this one's positive. So if I multiply all those together, I'm going to get a positive answer. So that means that my cubic has a positive leading coefficient and would look like this. Now we can actually graph it. So you don't actually need to even do that little step. You could just go straight to graphing it. If you were, again, if you had a test, you wouldn't have that option. You would need to know that this is what it looks like. Okay. So I'm going to pull up my Desmos. Let's do a new window. Okay, so I had y equals, I had 28 minus 2x, 21 minus 2x, and x. Okay, now when I first look at this looks like a straight line. So I need to kind of scroll around a little and see what I'm finding. Now, I'm looking for that little maximum here, right? That little hump. So I need to keep going up and up and up. There we go. There it is. So this is what I'm looking for here. So my x value is 3.96 and my y value is 1040.08. Let's write that down. So even if you hadn't figured out that this is what it's going to look like ahead of time, once you graph it, you know that's what it looks like. So this point here was 3.96 and 1040.08. Okay. So it says find the dimensions of the box. So we want to know the length, the width, and the height. The question is, well, what are these two dimensions? Well, if this is what I graphed this black equation here, V equals, that means that this was my X, and this here was my V, my maximum volume. Okay. So the reason I'm finding the point of this hump is because that would be my maximum that I have. I can't actually find a point at the end of this tail. This tail goes forever. So this doesn't make any sense if I think about this logically for that to be my maximum. I'm not looking for the point that was just on the edge of my screen. If I go back to my screen, I'm not looking for this point here. This is not the point I'm looking for. I'm not looking for this. This makes no sense because this is going to change depending on where I put my screen, right? So this point will not always be the same point. So that doesn't make sense that I'd be finding that. Also, it doesn't make sense that I would take off an x value of 16. If I took off 16 centimeters from both sides, that's impossible because my dimensions were only 21 and 28 to begin with. So I can't take 16 away from 21 twice. I'd have no cardboard left. So I'm looking for this maximum of the hump of the cubic. Okay. So once I have done that, I've found that maximum. X is 3.96. That's going to be my height. My height was X. Okay. My length was 28 minus 2x. So this is going to be 28 minus 2 times 3.96, which gives me 20.08. And my width is 21 minus 2x, which would be 21 minus 2 times 3.96, which would be 13.08. Okay, so I have my 3 dimensions. Okay. Another question that they might ask you in a question like this is, what maximum volume does that create? If we were asked that, we'd be giving this V value as our answer. It might also ask you to describe how you would solve the problem. You would just sketch a little thing like what we just did here. You'd sketch this little cubic and you would say, I would need to find the coordinates of this point here. You just wouldn't actually have numbers here. Okay, so you would say, I would need to find the coordinates of this point, and the x coordinate would be the amount that I'm taking out from the corners of my box. The y coordinate would be the maximum volume. Okay. So on a test, you wouldn't have Desmos and you would just sketch this. You wouldn't actually have all of these answers in blue here. You wouldn't be able to find those by hand. So we're going to do another problem with a quartic. Okay. This is a very, very common type of problem you will see. You'll have something like ages. Okay. And again, the hardest part is writing the equation. Once you have the equation, you're kind of good to go. You can graph it and move on. Okay. Now the problem is that a lot of people forget what things like sum and difference mean. So just to remember, if you have the sum of something that's adding things together, product is multiplying. And if you're talking about something greater than something else, that would be also addition. Okay. So we've got Clara and 3 of her friends were all born on the same day, but in different years. Leslie is 5 years younger than Clara, Mike is 2 years younger than Clara, and Thomas is 3 years older than Clara. On their last birthday, the product of their ages was 61,136 greater than the sum of their ages. How old was Clara and each of her friends on that birthday? So the first thing I'm going to do is figure out, well, I need a variable, and what does that variable represent? So because it's talking about Clara, I'm going to say that Clara's age is X. You can use whatever variable, C or whatever. I don't like using C because when I write really fast, it sometimes looks like a 0. So I don't like picking that if I don't have to, but you can use whatever. You can use A for age, use whatever variable you'd like. So Clara's age would be X. Okay, so if Leslie is 5 years younger, Leslie's age would be X minus 5. Mike is 2 years younger, so Mike's age would be X minus 2. And Thomas is 3 years older, so Thomas's age would be X plus 3. So now it's telling us about the product of their ages. So the product of the ages means you are multiplying. So this would be X times X minus 5 times X minus 2 times X plus 3. That would be the product of the ages. Okay. Then it's telling us about the sum of their ages. right? It's saying the product of their ages, and it's talking about the sum of their ages. So the sum of their ages would be adding them all together. This would be x plus x minus 5 plus x minus 2 plus x plus 3. Don't leave it like this. You need to simplify this. People always leave it and then they end up with this big, giant, gross thing at the end that they shouldn't have. Actually, combine these together, collect your like terms. This is grade 9 stuff. You can do it. So I've got x plus x plus x plus x. This gives me 4x. And I've got -5, -2, +3. This gives me -4. Okay. Now in the question it says the product of their ages was 61,136 greater than. Okay. So was usually means equals in an equation. Okay. Greater than means you're taking this and you're adding this to the sum of their ages. Okay. So you're having to read this left to right in a logical order. So this is saying the product was 61,136 greater than the sum. The product is this much bigger than the sum is. So you would have to take the sum and add this amount in order to get the product. So we have a lovely little equation for product. We have x times x minus 5 times x minus 2 times x plus 3. We've said that this equals to 61,136 plus the sum. You can leave it like this, or you can simplify the right-hand side. On the right-hand side, we can take this and actually subtract those if we want. So we can say that this is equal to 4x plus 61,132 if we'd like. So you have two options on how to solve this, okay? If one equation equals another equation, if we graph both equations separately, they are equal where the two graphs cross. So option 1 is to graph both equations. Okay, you would use Desmos. And when I say both equations, I mean the left-hand side would be one equation, the right-hand side would be another equation. You're going to graph them both. And then the second step would be to find where they cross, find where they intersect. Okay. And the x coordinate of that intersection point is actually the x from our equation. Which was Claire's age. Okay. So that's one option. So if I do that on Desmos, pull that up, we'll get rid of this old equation that we have here from our previous question. Okay, so we're going to graph two separate equations. We've got y equals x times x minus 5 times x minus 2 times x plus 3. That was the one side. The other side, whoops, this should say plus. That's why it's not letting me graph this. The other side was y equals 4x plus 61,132. Again, we're in a terrible viewing window here from our last question, but we also know like these are x values, and x value of 100 makes no sense. They'd all be 100 years old. So we know that we're probably not looking for something like that. Okay, we don't see a second graph here. I should have a second green graph. There's nothing here, but these x values would all make sense somewhere between the ages of 0 and 30. You could even go up to like 0 to 60, right? Those are valuable ages for people, right? So what we would do is we would want to keep scrolling upwards till we find where the other equation must have intersected. Now, we know the other equation is a linear and it has a y-intercept of 61,000. So I'm going to be scrolling up for a really long time. It might be helpful to zoom back out, scroll up till you find 61,000. And now you can start seeing that green line and then zoom back in. You can still see the faint lines on the bottom of the X values. We've got X values of 500 and stuff there. That makes no sense. Okay, so if I zoom in, I can see, okay, there's where they cross. If I find that point, I'm getting that they cross when X is 17. So that means Clara is 17 years old. Okay, so if I go back here, they intersect when X is 17. So Clara would be 17. And therefore, you can find the other ages as well, right? You know that Leslie's 5 years younger, so Leslie would be 12. You know that Mike is 2 years younger, so Mike is 15. And you know Thomas is 3 years older, so Thomas is 20. Okay. Your other option is to rearrange your equation so that it equals 0 and everything is on one side of the equal sign. Okay, so this would be something like if I had x times x minus 5 times x minus 2 times x plus 3, and then I would be subtracting the 4x and subtracting the 61,132, and then the right-hand side would now equal 0. You can also move it the other way. Then the second step would be to graph. You would only be graphing that one equation. You don't need to expand it, just plug it all into Desmos like that. And you'd be looking for the x-intercepts because it equals 0. So since it equals 0, you're looking for x-intercepts. Okay, so the x is same x as Clara's age. So again, when you graph it, you'd be finding your x-intercepts. You'll have an x-intercept of 17. The other ones won't make any sense. They'll either be negative or they'll be massive, like 500 again. And so once we pick Clara's age there as 17, we can find the other three. So there's really two main options. Again, if you didn't have Desmos and you were doing this on a test, the question would say, describe how to find how old Clara is. So once you have this big, long equation in black here, you could describe either of these situations exactly how I have here. Graph both equations separately, find where they intersect, and your x is Clara's age. You just wouldn't have the stuff in black at the bottom. You wouldn't actually know that x is 17. The other option would be to actually rearrange the equation and say graph that and find the x-intercept. Okay. Without Desmos, again, you wouldn't be doing this by hand. You would be describing how to. And that's all.